What I have here is wind speed data from Wisconsin. So this was done in 1998, and they set up different test sites in Wisconsin. This is site number 401, and they put poles that read wind speed, and I put poles at different heights. So I'm going to take one of these data sets and use them as if it wasn't just a data set, but my population. So here's my one data set, and this was the wind speeds recorded at a pool that was 10 meters up in the air. And I have, let's see, I got how many data values here? Looks like I have, it's off screen right here, 934 values. So I have 934 data values. Let's pretend for a moment that this is my entire population. If that's the case, and if I decide to take the average of this set, I have now the average wind speed, and standard deviation for this data set. Now, so if I say again, this is my parent population, that's all the numbers there is, then this value is the population mean, and this value is the population standard deviation. If I say this is just a sample from some population, then what I have here in reality is X bar and S, the sample standard deviation. So the X bar would be an average of 934 values. Okay, but for this exercise, just so we could understand the difference between the parameters of the population versus the parameters of the sampling distribution, I'm going to call this my parent population. My parent population consists of 934 numbers, and there are no more numbers. So this becomes mu of x, and this becomes sigma of x, and I'm going to get rid of these two. So now I want to take a look to see what the distribution of my parent population looks like. So I'm going to upload this data here. And here's my data that I say this is my parent population. I'm going to go to graphics, select histogram, and I'm going to select the wind speed. I'm going to let the computer figure out the bin width and the number of bins. And I get this nice graph, and I can see that wind speeds are right skewed. And this is actually pretty well known in the industry that that is the case. Wind speeds are right skewed. So most of the time we get moderate winds, and on rare occasions you get strong winds. Alright, so now I realize that it's right skewed. It's a right skew distribution. And because I'm saying this is my entire population, there's nothing else, we're also saying that this is the mean of this parent population. This is the standard deviation of this parent population. So now let's talk about sampling distributions. In this case, sampling distribution of the mean. Typically, well, in reality, most situations you don't know what this value is, nor do you know what this value is. And there's no way you can figure it out, just like I did here from the parent population. The best you can do is get a sample. So I'm going to get a sample from this parent population. So now I'm going to come over here. I'm going to click on data analysis. It's off screen right here, so you can't see it. I'm selecting sampling, I'm going to choose random. Um, here's my input range. Again, it's A3 to A3, no, 894. I'm going to pick 25 values at random from this parent population, and I'm going to put them here at, let's call it C4. I'm going to click OK, and this is my 25 random values. Now, what do you do with this in reality? Well, I don't have this number, so typically the whole purpose of this is to calculate the average of my sample, and with this sample of 25, I'll use that number to estimate this value, which I don't know. Okay, and that's what later chapters in your text do. It goes over that theory. But in order to make sense of that theory, we need to understand the distribution of these values. And notice the notation for this would be x bar, since I call this variable x. This would be x bar for a sample of 25. There's my one value. Now, in order for us to understand what does the distribution of all averages look like, I need to come up with a theory. Now, one way we can make sense of the theory is to try this out again and again and again and see what would happen. Once we understand the theory, we know how it works, we don't need to do this process over and over again, because we start beginning to understand how this whole thing works. But right now, because you're learning it, in assignment 3, I want you to repeat this process and then discover what is it that you get. So I'm going to do another sample of 25. This would give me a second average. Notice different from the first. I could do this again. And again. Each one producing a different average. So here's what I want you to understand out of this. This is a sample of 25. This is another sample of 25. This is another sample of 25. This is another sample of 25. These averages belong to the population of averages of 25 from this parent population right here. These averages come from an infinite population, consist of repeatedly sampling 25 from this population, creating a distribution of averages. What is now the mean, the true mean of these averages? Notationally speaking, this true mean of the distribution of averages would be called mu of x bar. That's the notation for this. Theory says that this value and this value should be identical if my sampling method, the way I'm producing sample after sample after sample, is unbiased. So these two should be equal to each other if there's no bias in this procedure that I've just demonstrated, the way I'm sampling. Theory also says the following. The standard deviation of these averages, which we'll call sigma of x bar, should be equal to this value divided by the square root of my sample size. So in this case, here's what it would look like. This, of course, is just an approximation because this is the true value. I can only get this if I sample forever, which I can't. But to give me an idea, if I take standard deviation of these 4 averages, I get this number right here. This is just an approximation of this value right here. Because I only use 4 numbers is not a very good approximation. But again, what is this number trying to mimic? It's trying to mimic the following. The parent population standard deviation divided by the square root of my sample. My sample is not 4, my sample is 25. So obviously this number and this number, you see them, well, they're far apart. Of course, because I've only sampled 4. That's why in the assignment I'm asking you to sample this not 4 times, but do this process 250 times. Because I know if you do this 250 times, this value and this value you generate by taking the standard deviation of the averages will be fairly close together. Notice, if I did this again, let me do it one more time just to make something clear here. Here I have another average. I come over here and let's just add one more here. Now I have a standard deviation of 5 numbers. Gives me this value right here. What about this theoretical value? I'm not going to change it. My sample size is 25, so it's this parent population standard deviation divided by the square root of my sample size. In other words, what I want to make clear is that this is my sample size. This is not the sample size that the theory provides. I'm just creating more and more of these to get a better estimate. Lastly, the one thing you also want to show is what does the distribution of these numbers look like? Averages of 25. Theory says it should be approximately normal. And that's what I want you to discover in assignment 3. That they're approximately normal. Again, using only 5 values, you can't possibly look at a distribution and see what is there. If you do this 250 times by creating a histogram of the averages, you can get a fairly good idea of what the distribution of sample averages looks like. Now, you should play this over and over again to get an idea and continue reading and looking at other things. But again, you might start to wonder, well, wait a minute, is this how it's done in real life? No. In real life, now knowing that we know the theory, we'll only sample once. Then we'll take this one sample, and using the theory that's been developed, we can do something else with this number, which is what happens in later chapters. We will do something with this number using the theory that we're generating at this moment. And then this will give us a good estimate of what this value is.